Are you tired of always taking the derivative of complex functions incorrectly? Have no fear, you have come to the right place. Welcome to The Chain Rule. Here I will attempt to teach all you calculus people out there exactly how to use the chain rule so that you can correctly differentiate functions. Get excited! In just a few short minutes, you will never bang your head against a table in frustration again. For the sake of time, I will make a few assumptions about you before I begin this tutorial. The first is that you are familiar with differentiation in calculus. I will also assume that you have a strong base in algebra. If this doesn't sound like you, then I would recommend finding another video. Now this is the actual chain rule as presented in most textbooks. It states that if you want to take the derivative of a composition of functions, you must multiply the derivative of the outside function, evaluated at the inside, by the derivative of the inside. I'll say that again, just so you remember it later. To take the derivative of a composition of functions, you must multiply the derivative of the outside function, evaluated at the inside, by the derivative of the inside function. So now you're probably thinking, what in the world does this mean? Don't worry, it will all become clear in a few moments. The chain rule works like a Russian doll. There's a tiny little function on the inside, surrounded by another function, sometimes even surrounded by a second function and a third function. The list goes on and on. The important thing to remember is that when the little function is inside the bigger function, you can't mess with it. If my Russian doll is all closed up, like the one on the right, then I can't play with the littler ones on the inside. If you understand this, you'll immediately be better at the chain rule. Solving chain rule functions requires two steps. The first step is to identify what the outside of the function is, then what the inside of the function is. In this video, I will color outside stuff blue and inside stuff yellow so you can see well and understand better. Here's an example. It's a very simple version of a chain rule problem. Looking at it, we can see that we are taking the sine of x squared. There are two functions here, one working on another. The outside is sine, the inside x squared. If you think about our original equation, x squared is like the g of x, and sine of x squared is like f of g of x. Here is a bit more complicated example. You can see that it is a quadratic function raised to the second power. Once again returning to the original formula, the power on the outside of the function, f of x, while the inside part, g of x, is x squared plus 1. Once you can identify the outside and inside parts of an equation, then you can proceed to step 2. Differentiate the outside and inside of the function with respect to x. Back to example 1. The derivative of the outside is cosine. But you must remember now what we said about the Russian dolls. If a function is wrapped up in a bigger function, you can't touch it until the bigger function is fully evaluated. So, in this case, we take the cosine of x squared. Now, since we have fully differentiated the outside of the function, we can multiply it by the derivative of the inside function. Same thing here in this example, just with a more complicated inside. We take the derivative of the outside, keeping the inside parts exactly the same. Once we have fully differentiated, we multiply it by the derivative of the inside. Yes, it really is that simple. Congratulations, you now know how to use the chain rule. There are much more complicated examples than what I have provided you, but trust me, the key to any chain rule problem is to identify the outside and inside parts of the function. If you can do that, the chain rule won't be nearly as daunting as you once thought. Warning, if you are still banging your head against a table, I highly recommend finding a doctor and possibly a psychiatrist.